Assalamualaikum. This is our group presentation about the multiple linear regression for the dataset website developer. So, this is our group members Abdul QAYYUM KAMIL bin IHSAN, HADI bin AZHAR dan AMIR Ashraf bin ZULKIFLI. So, this is our table contents. We have introduction, multiple linear regression, model adequacy checks, treatment of outlier, model refinement, special topic, conclusion and challenge. So this is our introduction. We have three objectives. The first objective is to determine which variables significantly influence the number of websites developed and delivery to customer per quarter. The second objective is to analyze whether the multiple linear regression model satisfy the assumption of model adequacy checking. The last objective is to identify the presence of outlier and influential cases in the dataset we have chosen.
We have chosen 5 variables to be included in our study. The first one is websites delivered. It is a dependent variable and also a quantitative one. It is number of websites completed and delivered to customers during the quarter. The second one is backlog of orders. It is independent variable and it is number of websites ordered in backlog at the close of the quarter. The third one, team experience. It is number of months team has been together. The fourth one, process change in website development process occurred during second quarter of 2022. If the value is 1, then it is in quarter 2 or 3 of 2022. For value 0, it is otherwise. The last one is quarter, which is for quarter 1, 2, 3 or 4 during a year. For the significance of the study, it is relevant especially for website developers and clients who rely on the services of website development. By analyzing the impact of process changes, allows company to implement data-driven improvements that enhance their workflow. Also, the quarterly trends in production can be recognized, which will help the companies to allocate their resources effectively. For the multiple linear regression part, we run an ANOVA test in order to find out whether this model is significant or not. So we got the p-value is 0.0001, hence it is lower than 0.05, which is the alpha. So we reject H null. We may conclude that this model is significant. For the estimated regression equation, we got the answer is y hat equal to 0.7459 plus 0.27075 backlog of orders minus 0.37438 team experience plus 10.38759 process change minus 0.66364 Q2 plus 3.6166 Q3 plus 1.496627 Q4. For the p-values for each predictive variables, which are the x variables, we can conclude that only backlog of orders and process change are significant in influencing the numbers of websites delivered, since the p-value is lower than 0.05. The second one is model adequacy checking. So we want to test whether our model follows the assumption of homoscedasticity and linearity assumption. So we run a residual versus fitted values plot, which shows that the points are plotted randomly scattered in the graph. So it means that it does not violate the assumption. The second assumption is normality. The first one is histogram of residuals, which shows that the distribution follows normal bell curve. For the second one, QQ plot, it shows that the points are scattered along the straight line. Hence, normality assumption is met. The third one, we want to test whether the error terms are independent towards each other. So we run a Durbin-Watson test in order to find out whether the value is near to value 2 or not. So we got the result is 1.395. It is not between 1.5 until 2.5, so it violates the assumption of independence of error. Next one is multicollinearity, which is to find out whether the predictor variables are highly correlated between each others. So from the table that is shown above, none of the variables have VIF values above 10. Hence, we can conclude that there is no serious multicollinearity happens for each independent variables.
For detection of outliers, the dataset contained 73 observations in total. While all data points were initially included in the analysis, the presence of outliers led to inaccurate results. Outliers and influential cases can significantly impact the magnitude and direction of regression coefficients. After further examination of the dataset, the analysis was repeated after removing outliers, resulting in a refined dataset with 53 observations. By eliminating values that fell outside the acceptable range, most of the variables in the study were adjusted accordingly. For student ties, the shape of the histogram appears fairly symmetrical, suggesting that the residuals might be approximately normally distributed. However, some deviation from normality may be present, as the histogram is not perfectly bell-shaped. If the residuals follow a normal distribution, it supports the assumption of homoscedasticity and normality of errors in regression analysis. While for standardized, the histogram appears heavily skewed, meaning the residuals do not follow a normal distribution. Most of the residuals are concentrated in a narrow range around 4.65 to 4.80, indicating potential modeling issues. The lack of symmetry and normal spread suggests the presence of outliers or heteroscedasticity, which is non-constant variance. Next, for the treatment of outliers. Outliers are extreme values that deviate significantly from the rest of the dataset. They can distort statistical analysis and mislead interpretations. The approach to handling outliers depends on their cause, impact, and the study's objectives. For histogram, the graph shows that the distribution of residual y against percentage with an evenly bell-shaped and symmetric in both sides, which shows that the normality assumption has been fulfilled. This suggests that the residuals are roughly normally distributed. While the tails of the residuals distribution shows some deviations from the normal curve, they are not highly significant. However, they do indicate a slightly higher probability of extreme values compared to a typical normal distribution. Moving on to the QQ plot, the plot shows that all the points are now lying near the straight line. This shows that the residuals are now normally distributed. There are minor deviations from the straight line at both extremes of the plot. The residuals at both the lower and upper ends fall slightly below the line, indicating the possible presence of outliers in the study. For box plot, it shows that the median residual is now approximately 0, which can be concluded that the residuals are symmetric and distributed around 0. The box plot also indicates that the model's prediction is unbiased. The next one is scatter plot. The graph shows that the points are now randomly scattered all around the graph. We can now say that the error term is inconsistent variance. This also suggests that the variance of the residuals remain consistent across different predicted values, confirming that the assumption of homoscedasticity is met. Thus, the homoscedasticity assumption has been fulfilled. The next one, which is for the outliers and leverage, we can conclude that there is no presence of outliers since outliers are only considered when there are extreme values that do not seem to match most of the other dataset. Last but not least, the Cook's D. From Cook's D plot above, we can confirm there is no other observation that could be influential outliers inside of the performance, since all of the other points do not exceed the cutoff point, which is 0.125 in the graph above.
For the model refinement, from the independence of error assumption in the model adequacy checking, the Durbin-Watson value is 1.395. So the value show that it is not independent. So we need to use the transformation to correct model adequacy, which is by using first differences. So after we use the first differences transformation, the value we get is 2.495. It is shown that the error of term is independent since the value is between 1.5 until 2.5.
In our study, we found out that we have dummy variables between the variables that we have chosen. The first one is process change and the second one is quarter. For the process change, it is a binary variable that contains value 1 or 0. Hence, it is already a dummy variable. The second one is quarter. It is converted into dummy variables to represent each quarters, which is quarters 1, 2, 3, and 4, with Q1, which is quarter 1, as the benchmark. So in the table that is shown, we can see the indication of dummy variable for quarter. For the Q2, only the value 1 is only at quarter 2, the Q3 at quarter 3 for the value 1, and the last one, Q4, for quarter 4. Q1 will be the benchmark or reference.
Lastly, conclusion. The conclusion that we get is the study found that the backlog of orders and process change significantly influenced the number of websites delivered per quarter, while team experience and quarter were not significant. The normality, linearity, and multicollinearity assumption were satisfied, but the independence of error assumption was initially violated. By applying the first differences transformation, this issue was correct and resulting that better to fit the model. Overall, the study focused on the regression analysis to provide the accurate result. The finding provide for website development team to improve production, which is by focusing on backlog of order and process change.